Well, we're considering reasoning and proof, and this is laying the groundwork that we'll use to develop proof statements as we continue along through this our course here in geometry. And we start off with inductive reasoning, and inductive reasoning is where we're looking for a pattern, maybe in some data or maybe in objects or whatever it may be. We're looking for those patterns, and then we're applying that pattern to make a conclusion that we call a conjecture. The conjecture is based upon inductive reasoning from the pattern that we see. And over on page 93 in your textbook, example 3, it says make a conjecture from data. And let's just read through and take a look at what we've got. It says the table at the right shows the price of postage for the years 1982 through 2009. And then we're asked to do a couple of things, 3 things. Make a statistical graph that best displays the data. And there's a number of things that we could actually do here, but in this video, I'm going to make this statistical graph using a stat plot in TI-84 calculator. It's something that we'll do from time to time in all of our math courses. And once we get the stat plot created, then we're going to get our calculator to give us a linear regression model. And then we're going to use that linear regression to graph the data, give us a line of fit in the data. And then from there, we're going to tackle part B of this, which is predict the postage rate in 2015. Now, obviously, we can sense the age of our problem here that's given to us in our textbook, because right now it's 2018. We're 3 years past that. And then lastly, we're going to make a conjecture. And that conjecture is C, does it make sense that the pattern of data will continue over time? And if not, how will it change, and explain your reasoning. So let's just look at our data here. So we got years in the left-hand column, 1982 out to 2009. And this is giving us historical data of what postage rates have done. So in 1982, first class stamp cost 20 cents. And if I look here, this is giving me, I'm getting information basically in 5-year increments, 82 to 87, 87, 92, 92, 97, 97, 2002, 2002 to 2007. And then this last one is in a 2-year increment between 2007 and 2009. And what I'm going to do when I graph this, I'm going to take 1982 as a 0 year. And then 87 is going to be, I'm going to set for the L1 or the x-axis is 5, and I'm going to enter it that way. And then on the postage rate, I'm just going to enter it like it is, going 20 out to 44. And then we'll see how we can make a prediction. And then we'll make a conjecture. Do we think this is going to continue over time? All right, so we're going to move over to our TI-84 calculator. All right, well, I'm over here on my TI-84 calculator, and I'm going to create a stat plot from this data that we have concerning the postage rates in the years going from 1982 out to 2009. And so the first thing I want to do is I want to get my stat plot turned on. And so I'm going to hit second Y equals button, which if I look just above that in blue, it says stat plot. And I'm going to hit enter. Right now my stat plot is off, and I'm going to turn it on. Let's see, I've got the cursor highlighted on, and I'm going to hit on. And I want to make sure the type of data I want, and I want this one that has just little dots of data. It's actually the first choice in the type. That's actually the stat plot. And you can see that it's going to pick up X list L1 and Y list L2. So from the list that we're about to create, it's going to give us an X and Y coordinates. Now I'm going into the stat button. And you see my first choice here is edit. So I'm going to hit the edit button, and I'm going to hit L1, which is going to represent my X values, and then L2. And if you recall from the previous slide, for 1982, I'm going to just set that as 0. That's my ending year. So I'm going to enter 0, and then arrow down. In 1987, I'm going to enter as 5. 1992, I'm going to enter as 10. 97, I'm going to enter as 15. 2002, I'm going to enter as 20. 20 years from 1982. 2007, it's going to be 25. And then 2009 is going to be 27. It's 27 years from 2002. Now I'm going over here to L2, and I'm going to enter this postage information. So we got 20 cents, and you may want to follow along in your book, page 93. 22, then 29, so it's 29 cents, 10 years out, 1992. 32, 37, 41, and 44 for the last year were given there in 2009. Now, before I go to look at this in a graph, I'm going to change my window settings. I got to be able to see it. So I'm going to go into window. Let's think about my data now. I've got X values going from 0 out to 27. But I also am going to want to make a prediction in 2015 and see, let's see, 2015 from 1992. How many years is that? That's 33 years. So I'm going to go to window, and I'm going to change my X minimum to 0. Let that be, and that's going to serve as the year 1982. And I'm going to extend my data out, X max, to 35. Because I know I'm going to want to make a prediction for 2015, which is 33 years later. And then on my Y minimum, let's see, we started out at 20. I'm going to just put 15 as a minimum, positive 15. And I know my largest year that from my Y data, my postage data, was 44 cents. It's going up every year. I know that. I'm going to put it at 55. Now let's go take a peek at the stat plot and see what we see. All right, and you can see here's all the data points that I have entered. Now I want to get a line of regression on this, and so I'm going to go back to stat, and this time I'm going to ask to calculate, and I'm looking at option 4, which is a linear regression. And you can, if you think about that formula AX plus B, that's awful lot like slope-intercept, Y equals MX plus B. And so I'm going to say I want to see a linear regression for that. So I'm going to hit 4, choose option 4, and then I'm just going to enter through here. And you can see that it gives me a formula. It gives me a little bit of what the slope is, what the y-intercept is, and then these R1s and R2s, they give me the correlation coefficient. How close is our data to this line? And this is 0.99, which means it's very close, very close. So let's see, I'm going to go take a peek at my data again. Now I want to get that line, that equation, into this graph. And so I'm going over here to y equals, and I'm going to put my cursor over here. And this time I'm going to hit vars, the vars button. It'll light up in red when I hit it. There it is. And now I'm going to statistics, option 5. And I say I want to enter an equation. And I'm going to enter this regression equation. That's the equation I just did when I did this line of regression. Oh, let's see, yeah, and I'm going to hit enter. And you can see it has entered that equation into y equals. Now let's go look at the graph. And you can see it's put a line of fit here. It's what best fits this data, and this is a linear regression without a doubt. And so there we've made a statistical graph that displays the data using our TI-84 calculator. Now I want to go to the next step, which is predict the postage rate in 2015. Well, 2015, we said, was 33 years from 1982. And so I want to see when X is 33, what's the Y value? In other words, what's it predicting that the postage rate is going to be? So now I'm going to hit second trace, which right above it you see calc. I'm going to hit it, and I got several options, but I'm going to say I want the value. I want to be able to put in a value of X and see what the Y value would be based on that. So I'm going to choose that option 1. And I'm going to say X, when X is 33, or in this case would interpolate to 2015, what's Y going to equal? And I'm going to hit enter. And you can see here that it says 48.771382 over here on the right, or let's round that up to 49 cents. So we would predict then that in 2015, based on the data that we had, remember we're dealing with some old data, that the postage rate might actually be about 49 cents. Now, third part. Does this make sense that the pattern of data will continue over time? Well, based on what we see, we think, yeah, it would. In fact, in the 2017, I think, postage rates, I don't think 2018 has been posted yet. First-class postage is, in fact, 50 cents. And so it's continued to increase over time. But what do we think? Is that going to continue over time? Well, it may. Certainly, that's the historical pattern. But then there's a lot of competition that has occurred in the postage rate market since 1982. I mean, email is, obviously, a lot of people don't even use postage department hardly ever because of email, and you can send attachments, and then there's text messages, and there's all types of message delivery systems through social media and such. And you would think that over time, as the demand for postage decreases, that the price would actually fall. Now, that's not been what's happening. And one of the reasons for that, and this is my opinion, is the Postage Department is a government agency, and they just don't perform like businesses do. And they don't have the pressure of earning a profit like businesses do, because they're the government. They get money, take our money. But anyway, so we could go either way. That prediction would really kind of depend upon your opinion. But if I were to make that opinion strictly from the inductive reasoning, looking for the pattern in the data and make a conjecture, then I would say, yeah, it probably will continue to go up over time. I don't know if in real life that would be true or not. But there we go. We've taken that data. We've made a statistical graph. We made a prediction. Now we're making a conjecture. Do we think it's going up over time? It would appear so. It looks pretty linear right there from what we see with this line going through this stat plot. All right, very cool.